Hello everybody, this is the first lecture of Introduction to Analog and Digital Communication. This is the name of the book. This is the Communication System course. The name of the book is Introduction to Analog and Digital Communication by Simon Hyken and Mitchell Moore, second edition. My name is Amr Abdul Bari. I'm with Nearest University. So this is the introductory lecture. So why we take this course? So we have here the historical background, application and primary sources, and theories behind the communication system. So to understand the science, it's necessary to know its history. This is by August Comte. So first, the telegraph. You know the telegraph. It's firstly introduced by Samuel Morse, and it's kind of very old communication mode that's using Morse code, some code that we normally hear about in the movies. Then the radio. It's the theoretical part is introduced by James Maxwell. And then it's demonstrated by Lodge over a short distance. Then the Marconi and other people introduced a longer distance. Telephone, the nowadays telephone, it's introduced by Alexander Graham Bell. And the electronics that we know, today, it's firstly introduced by Johann Elling, but the three people in Bell Labs, they introduced or invented the transistor, which is a basic for almost all the electronics today. The television is introduced by Franz Worth, and this is the first television, of course. And finally, the digital communication that is communicating everything nowadays. It's firstly introduced in 1928 by Nyquist, which we use his name as a fundamental thing in the communication system, communication theory. So everything here is based on something that is related to the first work. So the computer networks after that and satellite communication, all of them related back to the communication theoretical parts and optical communication, the fiber optics, of course. So the application, we can say that there is two kinds of main application of the communication: a broadcasting and a point-to-point communication. So a broadcasting here, this is the broadcasting. This is meaning that from one side, from a transmitter to multiple sides. So broadcasting means that I transmit to whoever can receive my signal. He can receive it and use the information. One example for that is the television, which uses satellite. It's broadcasting everything from out space, and whoever have a receiver for this satellite, he can receive the channels and he can see the information broadcasted using these channels. Point-to-point communication, it is like your phone and your friend phone. So it is from your phone to your friend phone. It's nothing else. So there is no other terminal that can receive your information or can discover what is happening or what you're saying or what you're transmitting. So a single receiver to a single transmitter to a single receiver. That's the point-to-point communication. So here we can see that is the basic components of a communication system is that we have a source of the information. This source is at the transmitter here, and we have the transmitter. This is the information in its basic elements. Maybe it is a voice, maybe it is a text, maybe it is application, for example. So this information have to be transformed to a type of information that can be transmitted over the channel. So we have this device that make it possible for this type of information to be transmitted over a specific channel, and so it's converted to a transmitted signal. Then the channel, we mean by the channel every media that we transmit a signal on it. So the wireless communication transmitting a signal over the wireless, over the air. This is a media, this is a channel. The sonar is transmitting a signal over the sea, within the water, for example. So in the your voice, your communication voice, you speak with somebody, you transmit a signal, and the channel here is the air again. Maybe there is a transmission over a different type of channel, like the wire, like the telephone wire inside the wall. It's maybe it is a copper wire or aluminum or whatever the material, or the fiber optics for higher speed. So all of them is a media. Whatever the media, this is what we call a channel, and each one of them have different characteristics. Okay, after the channel we have a received signal. Why it is different? Because there is an effect of the channel. There is a channel effect, there is a path loss, there is a shadowing, there is a fading, there is noise introduced to the signal. So this is different than the transmitted signal. Here we have this signal to overcome the problems that happen to the signal. To recover the original information, we have a set here of device. This device we call it receiver. This receiver know how the transmitter make modification to the original signal, original information. He knows what is the original information type. He knows what is the channel effect. So as possible as it can, the receiver remove all of this modification and give the estimated signal. Of course it is not the original effectively, maybe there is some errors, so the receiver is responsible also for discovering the errors and removing it. And finally we have the information in the same type of the source information. So here, if it is a voice information, if you call your friend and you use your voice, it's supposed to, for your friend to hear the same voice, your voice, at the same tune, at the same words, and everything is the same, almost the same. That's why we call it estimate of the message signal. That's why if the channel is bad, if the noise is very high, you can't hear what he's saying. You can't understand. Maybe there is cutoff or silence periods within the signal that you receive it from your friends. So that is the basic component of the communication system. Of course, inside this component there is a very complicated and different types and different complicated devices, but this is an overall view. Now let's see one of the most used communication system is the radio. The radio is broadcasting, as it is using AM amplitude or FM frequency radio, amplitude modulation. We will come later for this, or a satellite for satellite communication between a ground base station or a ground station to the satellite itself. So let's see here, if somebody speaking from this side of the earth and somebody speaking to this side of the earth, then they will use the communication over the satellite then they will use this satellite here. There is something called, we call it uplinks, which use some characteristics, frequency, amplitude, power, which is different than the downlink, which is go to this side. So the satellite has to know some information about the transmitter and the receiver. He has to control something, control these characteristics. He has to know the channel. Also the receiver, also the transmitter has to know some information about what's happening. They have to know which satellite they speak with, which what is the channel that they use, what is the bandwidth, what is the frequency, what is the limited throughput that they use, the speed of the communication, the type of the information that they. So all these control information, this is what we call the communication system. This is what built up the system. Now let's see what's happening in the communication network. Now we have a network that may be a circuit switching or packet switching. They store and store the message with a specific size here, and then they subdivide it to some segments. Then they send it to the receiver. The receiver take each sub packet and reassemble it in the same order, and then recover the original signal. For example, the network is responsible for the routing. For example, I have hundreds or millions of transmitter and receiver, and they send at the same time. So you here, for example, and your friends here, and you want to know how you can reach him. This is the responsibility of the network, the communication network. So if you are here, then how it's happened that the base station or the router in your home know where is your friend. This is another type of information. So to locate your friend and to deliver the signal, to deliver the message, to deliver it in a suitable time, it's happened to be a problem, and there is a lot of information that have to include it in the message itself. So the receiver, the original receiver, the mean receiver, by you specify a specific receiver, not all of them, or maybe you specify, for example, 2 of your friends. That is the responsibility of the communication network to identify all of them and deliver the message. Now let's see the data networks, the layers. So as I said, there is some responsibilities and some control that happened from different parts in the communication system. They define a reference model, a model that can be used in all communication systems, with different aspects, of course, for each one. They name it Open System Interconnection, OSI. This is it's composed of 7 layers. Maybe in some communication system it's less than that, but this is the full system. So here the first layer is called physical, second layer data link control, the third layer is network, fourth layer is transport, fifth layer is session, sixth layer is presentation, seventh layer is application. This is the full OSI model. Physical, in brief, physical is responsible for the channel and the bits that transmitted over the channel. So it's only responsible to receive and transmit here. The data link control is responsible for the reliability of the transfer. So here I transfer a bunch of bits. Here I should learn what's happening to these bits. Maybe there is some errors happening, so we have to control. So all until here it is some bits unknown. Here this is the network. This is responsible to deliver the this packet to the corresponding receiver or corresponding receivers. Here it is the transport. The transport meaning that end to end, the source to destination, the exchange between users. So I here include all the packet from the receiver to the transmitter and make sure it is delivered correctly. Here from this is the 4, here from 5 to 7 it's related to the device itself. For example, if your phone or your computer makes sessions of transmitting, so it's not giving, for example, if you open multiple application and each application, for example WhatsApp, for example, it's communicating with multiple users. So if it gives you some session with period and to control the communication between these users, and open the dialogue and close the dialogue. So it is like an in-between layer for controlling what's happening within this communication links, and close it if it's not usable anymore. Presentation, it takes what's happening here. This until here we speak about a row of packets and data. We don't know what is this data or component of. For example, maybe you send a text, maybe you send a file. What's this file? It must be, it is PDF, maybe it is Word, maybe. So the presentation here, it is a specific. So it's removing, for example, if there is a security encryption. So it's related again to a specific device and specific application protocols. That's because the application, maybe they share the same protocol, whatever I said in brief. So here it is delivered to the application in the suitable presented, that can you see it in the suitable presented media. If it is a voice, then it convert these bits to a voice, and it's now, and remove the encryption, remove everything, and deliver it to the specific application. And now it's already ready that you open WhatsApp and listen to the for example the video that you send it by your friend. Now the last layer, the 7th layer, is the application itself. Here the application itself, the application know all of them, and they know each step, and here they delivered the video, and here the application itself. For example, it make one sign that's it send it, 2 sign that is viewed by your friend, 3 sign that is he is typing. So this is the application level that you and the users and the customers of the application work with. The customer doesn't work with the session, if there is a session or not opened, if it's expired, for example. They don't know anything about the encryption, they don't know about security, they don't know anything about the routes, what's happening with their packet inside the network, communication network, for example. So this is the level of the application itself, the software that they use. I hope this is very clear, and this is a very little information. So the internet, for example, it's used same way of concepts about this or manners about using the OSI model. So I will skip this. So the internet use some protocols, voice over IP or that's kind of protocols. In each layer there is different kind of protocols, and there is protocols and stuff for the data storage. The storage, for example, the data in a video or a audio signal, but it's digitized, so it's everything is stored in your device now in 0-1 bits. So there is noise reduction, digital to analog conversion, so you can hear the audio. And there is another analog to digital conversion. Everything is digitized in our system today. Now the primary thing that we want to focus on and we want to remember, and we every time we describe a system, communication system, we think about two primary things. Of course there is a lot of aspects, different aspects, but for the main two is the transmit power, the power of the transmit signal, and the channel bandwidth. The bandwidth is the width of the baseband of the channel. I will come to this in detail later. But this is the power, and for example, let's say it now if you have a pipe for water, for example, the pushing of this water, the power that goes through the pipe, and the width of this pipe. This is the main thing about the communication resources, and this is limited, of course. So we don't have unlimited bandwidth or unlimited power. So even we have a power limited channel like the wireless channel or satellite or deep space links, or a bandwidth limited channel like the telephone or the television channels. Okay, so we have like a trade-off between the signal power of the signal and the channel bandwidth. We define something, I will come later, signal to noise ratio and the channel bandwidth. So you may increase the power, so you can enlarge the power to ensure that there is no error, or enlarge the bandwidths to ensure that there is a more bits sent, for example, for high ultra definition videos, for example, or video gaming, for example. It's need channel bandwidth to be very large, so you send a high throughput. So there is some theories behind the communication system. The main one of them, and elementary to know, it is the modulation theory. The modulation theory meaning that we have a phenomena of electromagnetic signal. Now this is the signal that's go through the air or go through the media in its own. Now I want to put some information on this signal. So the sinusoidal carrier wave, for example, it have an amplitude. If you have a sine or cosine signal, it have an amplitude, it have a phase, it have a frequency. All of them are the parameters that I can modify to carry information, any type of information. Also there is some kind of the basics, of course, the periodic sequence of pulses. So I have a pulses 1 0 1 1 1 1. So this is a train of pulses which have an amplitude, width, a position, and this is also a parameter that I can choose from and modify the signal so I can transmit it from the transmitter to the receiver where it carries some information. So to do that, I want to know what is the time domain of the modulated signal. What is the information of the signal at time t, or time t plus 1, t plus. So I have to have something like a time description. Also I want to know what is the frequency included in this modulated signal. So the frequency is something else I want to discover. Maybe there is some high frequency which is related to noise. I want to remove them. How I can remove the noise if I don't know what's related to the noise and what's related to the original signal. So another thing is the evaluation of this signal, and to know the original information and to know what is the effect of the noise, so I can remove it or reduce it as possible. So the basic mathematical analysis is Fourier transform, Fourier analysis, Fourier series or Fourier transform, which we use it to describe the signal in frequency. If we have it in frequency, we can use it to know the time domain. So it is very useful. It is a mathematical basis for know everything about the linear system, for example. The detection theory, it's another theory that we describe the signal. We have a signal which is have some noise. We want to recover the main original signal without any effects. So the signal maybe have some noise, maybe there is phase shift, amplitude modification, frequency shift. So all of these effects we study it through the detection theory, and to learn about the signal more, and to learn about the channel and how to remove these effects. The last thing is the probability theory and random processes. Normally the channel and noise is random processes, so it is randomly affects the signal. So you can't know the noise, you can't know the noise at a specific time. You just measure and later learn what is but you can't predict it, for example. But you can have some probabilistic information. So the average probability of the symbol error at the receiver at this time is like this. So you have an average, for example, average probability threshold, that if the information, the probability that you receive the correct signal or the wrong signal, if it is very high, then this is a prediction that this channel is very noisy, for example, or there is a problem, or you have to change this channel to another channel. So the probabilistic or probability theory is very useful to know, to understand better the behavior of the channel and the noise and the signal in mathematical terms, of course. So I speak today about that the communication system is very important, and we have many types of communication: radio, television, wireless communication, internet, satellite. We have much progress to do in the communication, and if you study it, you have to study the basics of the theoretical side, and then you learn the new technologies and theories that's happening today. So it is dynamic. And the last thing is that communication is affecting each life and affecting everyday life, and our lives will be much poorer if there is no communications system around us, our devices. And one of these is in these situations that we have all the communication that and devices that we can deliver this lecture for, of course. Thank you for listening, and see you next week.